find examples of this type of woodworking in nearly every room in your house, be it in the bedroom, in the kitchen, any place that has drawers and doors. And what I'm going to do is show you how those are created by using what's called rail and stile bits. So we have this dedicated set of rail and stile bits. You may have heard them referred to as cope and stick bits. And then finally, the large panel cutting bit in the center. And before we begin any real discussions at the router table, let's talk a little bit about design, because I think that's just as important when you're looking at raised panel doors. So my personal feeling is a raised panel door should almost act like a picture on the wall, providing interest in a room, where a raised panel door should do the same thing for the cabinet or drawer front you're putting on it. I like to think that the outside edge of this is the frame for that picture, and the center of this panel is the actual picture itself. So sometimes thinking a little bit about design can enhance the look of the actual picture without adding distraction to the frame around the outside. And here's what I'm talking about. This particular panel is made with a raised panel bit and is used with flat sawn lumber. And you can see in here we have a controlled cathedral pattern. And what it does is it adds a lot of interest to that, and it pulls your eye towards the middle of this door. The outside edges here are also flat sawn, but what you're not seeing with those is any real wild grain. And maybe before I go too much further, let's talk about that part itself. The first is, this is flat sawn material. It has a pronounced cathedral like this, and generally that cathedral is closer to the middle of the tree, the pith part of that. And the outside edges of the tree, or that lumber, get a little bit straighter. So you can see it here, but another way to identify it is look at the end grain of flat sawn, and you'll see that the end grain generally runs parallel to the end of that board. This is a log lying on ground flat and just slabbed off. They get the most use out of this material, and it's called flat sawn or plain sawn. The second material, or the second cut, is what's called rift sawn, R-I-F-T. Here, the grain lines are pretty straight. They add a lot of uniformity, and to be honest, are kind of more of a gentle blend without drawing attention to themselves. This is another way to cut wood, and what you'll be able to see on the side of this is the grain direction on here is diagonal with the end of that board. So it's just the way it's oriented when they cut that from that log, and again called rift sawn. And the last one is called quarter sawn, and in here hopefully you can see what's called raise and flex. Those are little feeding tubes that go up and nourish the tree, and they're cut at a bit of a bias so they show up. So they have a really nice, almost luminescent look. You can tell this cut of wood by looking at the end grain here and seeing in that case, it's all but exactly 90 degrees to the end grain. So those are the three different cuts of wood. And the reason I'm explaining that is that let's just say you're trying to use a flat sawn material and you're getting an awful lot of grain direction in it, and you really don't want that. Well, you can take that same species, this is oak, and make that same door out of what's called rift sawn. So here you'll notice that the stiles and rails are nice and straight. The grain looks pretty even, and it definitely does not detract from the center. And yet the center of this is fairly, I don't want to say bland, but a lot more continuous with the grain flow around here. This is particularly important if you're using this type of construction to do drawer fronts. One of the other big monikers in rail and stile construction and flat panels is that if your wood has cathedral grain like this, it always needs to point up. People seem to be more comfortable, more mentally happy when things are pointing up. Think stock market. So the idea is that's what I want to see in here. But I have an awful lot of areas on here that go in different directions. And if this same cathedral is used in what we call the side pieces here, the rail parts, do we have that arrow pointing this way? Do we have it pointing that way? Do we have the top and bottom pointing at each other or away from each other? So it can distract from the center of this panel. So for that reason, you may want to look at the edges of a flat panel part and find the edges, that wood, and find the edges of this where the grain is slightly straighter. That will make a much nicer look around the outside that won't detract from the front. So you've got a couple of different ideas as to what you need to do for those drawer fronts. Here's another example of an issue. This is a glue up, and you'll notice on here that I have a cathedral pattern to it. Okay, let me do this. Put a little bit of mineral spirits in here to just highlight this. And you'll see that grain pattern is pretty pronounced. But you'll also see that the pattern itself is off to this side of the board. So if I use this as a raised panel in the center, it's going to push itself off just a little bit to one side, and it could wind up being distracting. So if you're gluing up a panel like this, just make sure that there's enough material on one side and the other of that grain, if that's the plan you're using, to balance it. Okay, it's all part of that little glue up. Secondly, here's one that's also a glue up, and again, adding a little bit of mineral spirits to this will show it a little bit better. This is two boards. They both have cathedral in them. The cathedral is centered pretty well in both of them, but in this case it's pointing up, in this case it's pointing down. It just is confusing. And to me, once you can eliminate some of that confusion and draw your eye to the middle of this panel as opposed to the extremities around it or the confusion around it, you'll have one of those projects that when people come to your home and they see something you built and say, that's really pretty. That's just beautiful. As opposed to looking at it and saying, yeah, I see you built that. So the idea is fairly subtle, but it all can be handled during the original layout of this. So when you're doing your material layout, using a piece of chalk to kind of decide which parts you want, remembering that the grain pattern, if using them, that is really striking, be used for the center of that board, the panel, and find something a little bit less distracting around the outsides. This is also two pieces here, and the colorations are pretty close. But to be honest, if you're doing a glue up with 4 or 5 different pieces, this is red oak. But red oak is it's really not red. It's brown, it's tan, it's yellow. And if you're putting a bunch of boards together, make sure that the coloration in those is all about the same, because it's awful to try and put those boards together and then try and stain them to make them more uniform when they didn't start out that way. And if all the material you've got is some dark and some light, then use that to your advantage. Have the darker pieces closer to the outside and the lighter in the middle, or reversed. And as long as all of your doors look like that in this one bank of doors or drawers, you'll have that uniformity again. And again, the difference is the craftsmanship look on something as opposed to woodworker. Now, there's nothing wrong with any of these. The construction is fine. The glue joint will never come apart. It has nothing to do with the durability of this particular project. What it has to do is that ethereal quality of it. So using these ideas can really help. Well, here is how I do my preparation for layout for a door. I will measure the overall door that I want. In this case, I have a hypothetical door that's going to be 12 inches by 18. So I'll take a piece of the builder's paper like this, and what I'll do with this is I'll transcribe those outside dimensions to the sheet. So I'll be coming across 12 here and 18 here. So it kind of gives me a good feel for the outside edges. To be honest, one of the reasons I use this is because I'm terrible at math. And I prefer, in most cases, to mark instead of measure. But this allows me to kind of do both. So if I have my 12 by 18, I can now say that I want to put my rails and stiles in. The stiles and rails, generally, the thickness of those is 3/4 of an inch. But I'll suggest that more importantly, that they're all exactly the same thickness. Because when you're doing rail and stile joinery, you want the ultimate joint to come out smooth on the top and the bottom. So if you don't have a way to thickness plane or drum sand your material, maybe by buying one big wide long board, you can cut all those pieces out of there and be pretty assured that they're all going to be the same thickness. Secondly, the widths of most of the, for stiles all but for sure, is normally a minimum of 1 7/8 inches and about 2 1/8 or so on the other side, maybe 2 1/4. And the rationale for that is when you're putting Euro hinges in, the back edge of that Euro hinge, the cup that's in there, can sometimes on relatively narrow stiles cut right through the profile in the front of this. That's a bad thing. So what I normally do is I suggest that I like my stile widths to be 2 1/4. And the lengths of those run from top to bottom. So if I know that, I can take my outside dimensions, add 2 1/4 inches to each side, and that gives me the layout for at least the first part of this. What it'll also do is tell me, secondly, how long these rails are, the bottom and top parts. Now, as far as their width, they can be the 2 1/4 inches to match the stiles that you put on, but there are some design considerations where some people like them a little bit bigger on the bottom, maybe a little bit smaller on the top, and that's more of a decision for you to make. But in general, I'm just going to make this all the same dimension. It's easy then to kind of see what I'm doing, and then you can make adjustments depending upon what you're planning on matching or your particular style. So if I have my 2 stiles already measured on here, to find the length of this rail, all I need to do is measure across here, which is 7 1/2 inches. And I know that because the groove on the edges of those stiles is about 3/8 of an inch, I have to make the rails this width, and I have to add 3/8 of an inch to the left and 3/8 of an inch to the right. So what I've done on my markings here is I show that to get the length of this rail, I know this is 7 1/2. If I add 3/8 to this side and 3/8 to this side, I wind up getting 8 1/4. And that's the length of this piece. So it makes it real easy to lay this out. And lastly, when the time comes, I'll be able to easily get the measurements for my raised panel or my flat panel by just measuring between here. Now the reason for that 3/8 is that this is the bit for the stiles. It's going to cut a groove from top to bottom. And that groove's depth is about 3/8 of an inch. So when I do that, I know that the tongue from the rail that's going in there has got to be extended by that. Here's a more visual look, I guess. You can see through the bottom edge here that this is the depth of that groove. So I've just got to make sure the piece that's going in there slides all the way into that part. So, and again, I know it sounds silly, but if I'm making a whole set of doors and they're not all quite the same, maybe the tops are different than the bottoms for whatever reason, by having a layout like this makes it so easy for me. And now I know I can cut all of these to size by the table saw or your miter saw and be pretty comfortable when I go to the router table that what I'm working on is correct. When you do cut all those pieces, cut at least one extra rail and stile. It gives you a chance to kind of play with the adjustment of those before you commit yourself to doing them all. The cope, which is the joint that's at the end of this rail, is the one that I'm going to put on first, and I will adjust the stick on this stile to fit that. So with all of these pieces cut, everything set, I'm pretty much ready to go. Last thing, when I put these on here, I can actually lay out these pieces and I can align them for what I want to see on the outside. So I kind of like that little knot that's in here. So if I lay these out, and this is the way that I want to see that, so this would be my finished look. I know that all routing for the profiles for rail and stile bits on the router table are done routing from the back side. So what I want to do then is I want to do this and put the back side out, and I'm going to mark each one of these. So X marks the spot. So when I'm going to the router table, I know that as long as I see the X I'm routing the correct side of that piece. Again, doing one door, probably not a big issue, but you're doing a lot of them, and it's really not that hard sometimes to route the joint here and route the joint here, and you'll be out of your mind. So having the X on here means that if I route this one and route this one, and I can always see the X, I know that I've got it right. So that's my general layout. So it makes it much easier for me now to go to the table. We'll take this material over the table, and I'll start by showing you how the bits are set up. We'll do the cope one first, that's on that rail, and then we'll show you how to make the adjustments to do the stiles. Now to begin, I'm going to do all of the cope joints first. They're the ends of the rails, like you see down here, and that's where I like to start. There's been some debate about this as to whether or not you do the cope joints first and then the stick joints, or the reverse. I really like doing the cope joints first, and I do it because I think there's more material on that end. I know what the finished lengths are going to be, and it's much easier to me to adjust the stick bit, the one that cuts the grooves all the way around, after I've gotten all the copes done. You can do it either way, and if you've learned one way, then stay with it. But this is the way I like to do mine. So we have two bits here. The one on the left is the cope bit, and the one on the right is the stick bit. Now at first glance, they sure look a lot alike. And trust me, from personal experience, it's exceptionally annoying, to say the least, to take the wrong bit to do the routing you're planning on doing. So the one on the left, if you'll notice, the bearing here is in the center. And center starts with a C, and that should stand for cope. But I've also put a little red magic marker in there that's got a C on the shank, and it tells me this is the bit that I'm going to start with. Now there's only two bits, so you really don't have to put any markings on the other one. This is the stick bit. This cuts the grooves on all four sides, insides of a door frame. It's got the bearing on the top, and I also put a small little S down inside. But I'll start with the cope bit. I'll put it in the table, make some of the preliminary little adjustments, and I'll bring you back to show how to adjust the height of that and its proximity to the fence to create that cope cut. I put the bit in the table. I've slid the face of these fences up nice and tight against the edge to kind of eliminate any play inside there. And I put a clearance plate in the bottom again to kind of tighten up all those edges and make sure that I've got a nice snug fit for that bit. When I set it in there, one of the first things you'll have to do is make sure that the bearing that's on that bit, and remember that's in the center, is sitting flush with the face of the fence. So you just put it straight up against it, straight edge against it, make sure it's touching the face of the fence in both spots, and just touching that bearing. The reason we're doing that is that will give me that full 3/8 of a cut. So I want to make sure that those things are all aligned. And you're doing that generally with any router bit you use that's got a bearing anyway, but it applies in particular to this one. Next is setting the height of this. If you look in here, so this little cutter on the top, the bottom edge of that needs to be 5/8 from the table. This will give you enough material above and below that joint to add some decorative element, but also give you a real nice solid glue surface. Now the manufacturer that supplied these bits also supplies a little setup block like this. Kind of nice to have these. This is the cope side, and if I use that on the table, I know that I just have to lower the bit until it touches the top edge of that block. And to remind myself about how tall that is, I know that from the bottom edge of this, which is the table surface, to the top edge here is 5/8 of an inch. So that'll get you there for your first setup. Now, we're going to be doing, again, we're going to do just the rails, the small horizontal pieces, and we're going to be doing the ends of each of these. And remember, you always want to see the X. So that goes up against the fence, and it crosses the front of that bit. One of the issues is, because it's long and narrow, it may not trail too well, probably won't, on this fence. And any kind of movement will mess up that cut and get your hands markedly closer to that bit than you want it to be. So one of the ways to get around that is just take a piece of MDF like this. You've got plenty of scrap in the shop. This is 3/4 inch. And I put a hole in the bottom of it, or in the middle, so that if I put that up against the fence and index my piece of trim up against it, I can hold these together and I can run them past the bit. And as that spinning bit is going this way, I won't have any tear out on this edge. And that works. If I'm doing a door, I'll have 3 of these, because I'm always suggesting you make 1 extra. So I'm doing 6 of those passes, 1 on each end. If I were making a lot, it just gets very tiring. So though I can do that, I'm going to prefer to use what they call a coping jig or a coping sled. This is one here. This is a shop-made coping sled. It's made with multi-ply plywood, a couple of hold downs in here, a handle in the front, just a 3/4 inch dowel, and a self-made handle in the back. And it rides flat on the table. And the opening that's in here allows a space to hold that piece of trim as you're doing it. And what you do is you index that against the fence face, you slide this piece of trim up against it, and lock it in. So now instead of pushing it with a little block, I've got it held real well in here. And again, as that spinning bit is going this way, this piece on the end will act kind of like that piece of MDF and keep that chip out from happening. So what I'll be doing is I'll turn on the bit, we'll press this into the bit, and we'll run past it until I'm sure, and then take it out, and then pull up these clips, turn this around while always making sure I can see the X to do the second side. And I'll be able to do that on all of those. And when you're setting this up the way you have, you're going to cut all of those copes at the same time. You saw how we measured them, you know that they're the correct size, so you cut all of them at one time. There's only one big difference here though. Now that I've got that jig in here and the bit, the jig itself sits about 1/4 inch above the table. So I've got to raise this bit to make up for that difference. So I'll make that adjustment, we'll come back and I'll do these. Whatever jig you use, if you're doing the block, you don't have to make any changes because this sits on the table. If the jig that you're using is higher or lower than this particular one, you'll make those adjustments after the fact. Or you can just take your setup block and actually set it right on the jig and let that make the adjustment for you. Either way, it's kind of your choice, but they work really well. So let me readjust that bit. We'll come back here and I'll show you how to make those cope cuts. So these are my 2 edges. Again, cleanly cut here, a very nice exit here, and the same is true there. And again, I'm always looking at the X. Now ultimately, when this is put together, it will join like this. But the cut itself is always made good side down. Let me do the balance of these, and then we'll talk about doing the next bit. That's the stick bit to cut the grooves in all of these. So I've run all of my cope pieces, and I did 3 of them, so I've got 1 extra one. And now it's time to do the stick cut. Now the stick cut provides the complementary profile on the tops of those stiles as they come down this way, and it also provides a groove for the inside edge of all of these. So I've got it mounted in the router, and again, it's the one with the bearing on the top this time. I've lined up the bearing with the fence exactly the same way. And to be honest, once the fence is in place, when you put the new bit in there, that bearing should line up automatically. And I've raised it to a point that I want this cutter that's sitting in here to do this. Now on the piece I cut previously, this is the tongue that sticks out of that cope. Remember again, we cut it with the X on this side. So this is the tongue. And if I use that piece and I make sure that this cutter, you can see it on the top edge here, that's the one that actually cuts the groove. So if I match up that cutter with the height of that tongue, I've automatically got the groove in the right spot. And this is why I like to do all of the copes first. It gives me a way to lay out the stick, and when I'm done with this, I'll see how that fit is, and if I have to raise or lower it a little bit, by raising and lowering that bit, I can bring that alignment perfectly. So the other thing you'll see here is that with our first cope cut, I was able to do this flat on the table. And by holding either a block of MDF or my coping jig, it kept it pretty stable. But on these, you only get one pass, and it's got to be down on the table and up against the fence. So we're putting a series of pressure boards in here. This one keeps pressure on the board as it's going through from here, and this one, when I place it, is going to keep pressure to keep it up against the fence. So these two pieces are now holding that in line, and as I pass it over that bit, the groove will be cut down the middle of it, and you'll find that the profile is just perfect. So again, I've got the bit speed set at around 15,000 RPM or so, which is what I did with the first one. And I've got this one in place. You'll need a push stick like this. These are always a little tricky because depending upon the design of the pressure boards, sometimes these nuts and knobs stick out pretty far. This one seems to work pretty well on an end like this, and I can push it through. And again, the goal is slow, easy press from one side to the other. So let's get started here. I'll put the vac on, we'll turn on the router, and we're ready to go. And now this is the test. These pieces fit perfectly. The tops and bottoms are aligned beautifully, and the tongue is completely inside that groove. This is the way it's done. Now that I know the fit is good on this test piece, I can finish making all the stick cuts in the rail and stile pieces. All right, well, I've assembled this frame, and you can see how nicely and cleanly each one of these edges turned out. There's a groove all the way around the inside, and the cope and stick joints fit perfectly on the end. And because we were able to measure these and know exactly how well they were going to fit, I can lay this directly back down on that pattern, and it fits. So it's kind of a reinforcement for me that what I was thinking about works. So now the idea is, once I've done this, I have an option to put a panel in the center, and I can either do that with a flat panel or I can do one with a raised panel. And they can be made out of a couple of different types of material. Flat panels in many cases are made out of veneer. So we can take a small piece of plywood and insert it into there. The groove is 1/4 of an inch wide and 3/8 of an inch deep. So all we need to do is add those dimensions to it and drop that panel in there. Most of what you see, though, are panels made of solid wood, and those panels can expand and contract, so I can't make them fit the exact opening. So if I look back on my sheet again, and I make my little subtractions and additions, if this piece is 7.5 here, and this piece is 18, and I subtract 2.25 from 2.25, and that's 4.5, so that would be 13.5. That's what I know that I will cut my panel to fit exactly in that opening. But I know that I want to have it inside that opening, otherwise it drops right through. Well, if I add the 3/8 of an inch to one side and the other, and the top and the bottom, it'll fit in there perfectly. But unfortunately, it's jammed in there. And one of the ideas behind raised panel is you have to give it room to expand and contract. Here is a panel done that way, And you'll notice, hopefully, that that panel actually has a little bit of movement in it. And it's because we've allowed a little bit of extra space. So what I'm going to suggest, and depending upon how big your panel is, you're going to add the full dimensions along with the 3/8 on either side. So in other words, 3/4 of an inch bigger, and subtract from the height and the width 3/16 of an inch. And if you think about it, instead of going all the way into those grooves, it's going to sit about a 1/16 of an inch short or so, so that panel can actually expand 1/8 of an inch back and forth and not get out of that enclosure. So depending upon what your size is, and again, you'll be able to measure these depending upon what they are, measure it as though it were fitting all the way into all of the ends. And then from that measurement, take 3/16 inch off the height and the width, and you got it. Now, one last thing. When you do these panels, the material normally is 3/4. And you'll notice that the grooves that are in here allow for that. The difference is, once I've cut that panel, it's going to sit inside that groove, and there'll actually be a reveal on the back about 1/8 of an inch. Now, I kind of like that. I think it's a nice look. It gives an extra bit of appeal when you open the door. The problem with it, though, if that is a problem for you, is that also means that this panel sits 1/8 of an inch above the frame of this. So above the plane of this door, this sticks up the amount that it's indented here. So again, a couple of options. The first is, like this one, you can just use 3/4 inch material. That gives you the 1/8 inch reveal on the back and gives you a little reveal on the front. As you look straight at the cabinet, you won't see anything. If you were somehow able to get right up against the edge of those and sight down, you'd see the door panels are slightly proud of the frame. And again, that is a design element, and a lot of people like that. There are two different types of bits to cut these panels. One of them will cut a groove on the back that matches the amount of overset, which automatically means if it fits in flush there, it's flush with the top. And this is the idea here. So this is a piece of walnut. The normal edges are put in here, and the bottom edge here has been rabbited in effect to make up for that difference. So this little piece that's sticking out will fall deeper into that opening, which will make it flush with the back. And because we've reduced it 1/8 of an inch, that means the front will be flush. Now you can buy one of those bits, and we'll talk at this at the router table in just a second. I'm not a real big fan of these. They're very hard to adjust. You can't raise the bit to take a little bit of material off to make this fit or route easier. And the problem with that is that as you try and raise it, you cut through all those profiles. So you have to block out the fence and slowly move the fence away from the bit and then forward from the bit to be able to provide that offset. I'm not a real big fan. If you want, you can just make this panel as it is. And then on your table saw with a dado blade, just take 1/8 inch deep by 1/4 of an inch wide plow around the outside edges. That accomplishes the same thing as that bit. Pretty cool way to accomplish two things at one time and be able to make an easy pass with the router bit. The other way, and I like this, if you are able, instead of doing 3/4 inch material, just do 5/8. The profile will be exactly the same on the front, but what happens is it's not thicker. What you'll find is that now, because it sits even with the top edge of that bottom groove, the panel only sits up 5/8 of an inch instead of the full 3/4, and you won't have the extra 1/8 inch sticking proud of the top. A lot of decisions, I know, and that's probably part of the fun of woodworking, but that gives you a feel for some of the things you're looking for in this. Well, I know what the sizes are going to be. I can probably do what I'm thinking about doing, and that's what the average person will do, and use a 3/4 inch board. I'll take that over to the router table. I'll show you a variance in the types of router bits you can use in the router table, and then we'll make that pattern. But I think you'll agree the technique for laying this out and cutting it, again with an idea of cutting the copes first and then the stick joints, provided a beautiful edge with no chip out. I think it works. That's why I like to use it. I'll see you at the router table. Well, I'm back at the router table to finish the last part of this rail and stile build with what will ultimately be a raised panel. Before I start, if you remember, I was telling you that some companies will send you or include in the kits these little setup blocks to allow you to set that coping bit a little bit easier. So this is the one that I showed you when we were doing it. Well, once you get done making your rail and stile, especially the sample pieces, take those completed pieces and cut small ends off like this. So that now in effect what I have is here's my setup block. So if it were me, I would leave these couple of pieces along with the kit of bits. So when you're ready to do the next time around, if you don't have one of these little setup blocks, you'll have one of these instead. Okay, so now you've got a couple of different options in routing this panel. This is the standard bit. In many cases comes with the kits. This is a raised panel bit, and it's called a horizontal bit. And I'll put it in the router table in a minute and do all the setup and things, and then we'll show you how to do the passes. But the gist of this is that this sits in the table flat like this, and you slowly raise it to remove more and more material in multiple passes, which is easier. And this is a fairly heavy-duty router. I've got a 3/4 or 3.5 horsepower router in there, and it's pretty big, and the table is pretty robust as well, so I can turn that bit no problem at all. If you have a much lighter bit, let's just say you're using an old style router that's a horse or a horse and a half, it probably still has plenty of power, but if you're a little bit concerned about it, there is another way to route raised panels, and that's what's called a vertical panel raising bit. So it stands up in the table. Because it's not quite as wide, it doesn't take as much power to turn that. So there's less torque needed, and you can get away with a slightly smaller motor. The only reason I really don't like using those, and I would use them if I had to, but I won't if I don't, is that they have to stand up on the table like this. So instead of being horizontal, that vertical spot means that when I route something, I'm trying to stand the board up like this, and I'm trying to keep it stable on this as it passes that bit. So I'm doing the end grain, the edge, the end grain, and the edge, and so on. And the only way to make multiple passes is to set your fence forward, make a full 4 pieces, and then slowly move it back and take more and more bites each time. It can be really time consuming, and to be honest, it's troublesome. So those two options are there, so you can decide which one you want to use. If it were me, and if you have any options at all, I would suggest staying with one of these horizontal bits. So that being said, let me get the router table set up. I'm going to change inserts because this one won't fit in there. We'll change the opening of the fence here, and I'll be setting the router speed down to about as slow as it'll go. This is a really big bit, and the outside edges of this are literally flying around there if you're trying to do this at 15,000 or 25,000 RPM. I think this particular router goes to around 8, so I may lower it to 8 to 10,000 or so. It may seem like the bit's going really slowly. It's really not. It's the outside edge that is really moving around at 8 to 10,000 RPM. So that's the idea. Give me a second to set this up, and I'll be back in just a minute. Okay, well, I've set the bit in the opening. I actually couldn't find a insert in there that's large enough to do this, so it's just kind of sit like it is in there without one. And I've slid the fence about as close as I can get so that the cutting edges are not going to make contact ultimately with that. Now the idea is, as always, whenever I'm routing on a router table, I'm going from right to left. And whenever I'm doing a piece like this, and I'm doing all 4 edges, I always do end grain first, then edge grain. And the reason is, as that bit is turning this way, there's a real good chance that there'll be some tear out on this corner. And if that's the case, once that first cut is made, and I rotate this board and route it this way, that tear out to be removed. So as long as I remember each time to do end grain, edge, end grain, edge. I'm going to do the first one, and once I route that, then I'll be raising the bit a bit and then doing it again. So I'll kind of make multiple passes here. You're certainly not going to want to see them all, but I'll make multiple passes to get this started, slowly raise the bit, and ultimately I want to raise it until the edge here is about 1/4 of an inch thick. And the reason for that is that I want to fit it in this groove. Remember, again, these are the grooves that that stick bit cut all the way around. So very near the end of this, I'll make sure that I'm really close. I'll make one final pass so that it fits in here, not super tight, but just enough to be able to get it to slide in there, and then I'm done. So again, this is an exercise in patience, slowly raising the bit. Don't get carried away, because as little as it looks like it's going to take off, it's taking off a lot at one time. You'd be surprised how much material is going through there. Okay, so let's start. Oh, I should mention one more thing. See the X there? It applies to this board as much as it did to the rail and stile. This is a spot on the board, will probably come out of there. It's a little mark, I don't know what it is, but I want to route on the opposite side. I want to make sure that the face of this is the one I want to see, and that's over here. So I am going to route with the X pointing up so that I know that I've got the correct side when I'm done. This is my first pass. Now that's the first pass on here, and you can see it's already done a pretty good job of taking material away. And again, this is the patience part. So I'm going to raise the bit and take another pass. And it's really hard to say how much to raise the bit each time. Every wood is different. Some are a little bit more dense than others. Some are a little bit easier to route than others. So taking your time and being patient will allow you to make multiple passes without overtaxing the motor and still being able to do a real nice job. It may take a little while, but it's worth it. So let me get this really close and we'll come back when I'm ready to fit it. Okay, so we've made our multiple passes on there. I finished up with one real light pass at the very end, and all I want to do is make sure that my piece just slides on here. It looks like I've got to make one more. I do. One more quick pass and I'm done. Now again, this is the fit that I want. I don't want to have to pound it in here, but I don't want it to be so loose that it's a little floppy. So this is just perfect. So now that we've made our passes all the way around, and again, end grain then edge, it looks really nice and pretty, nice and flat. So let's go over to the workbench and let's finish up showing you how to end this project. Here is our completed panel, and it's going to fit inside these grooves that we cut earlier. And you've already seen by testing it with the sample piece that it fits real nicely. Not too tight, not too loose. But a couple of things. When I put this in there before I assemble this joint together, because I can't get it out after that, I want to make sure that if I'm planning on staining or finishing this panel, I make sure I do that first. As this panel expands and contracts, and if I put it into this opening, as it moves, there's no way I can get that stain or that finish down underneath. I did a large bed frame for my son with multiple raised panels in it, and I did a finish with a stain and finish on each one of those panels before I inserted them. So if you're planning on staining, my suggestion is put one coat of stain on here, then at least 2 coats of finish. Let it dry, set it into the opening and glue all your joints. Once you've done that, tape off the parts that you've stained in here and put your coat of stain and 2 coats of finish on this. Once you're done with that, pull all the tape off and put one last coat of finish on everything. That way you're sure that whether it expands or contracts, you're not going to show those shrinking lines. it makes a really big difference, and it's much harder to do later on. Again, this works exceptionally well, and you can design these for any size project you want. So you can see that the whole process itself is pretty simple if you take it one step at a time. We've done the rails and stiles here. These are the rails, these are the stiles. We cut the copes on here first, and I showed you how to do that. Then we cut the grooves all the way around with the stick bit, and I showed you how to do that and how to make any kind of adjustments to make sure that these edges are all even. And then finally, how to use the raised panel bit to do that panel. Once you get the idea, you can play a little bit. You're not that far away then from doing something like this. I added some different colors in here because it's scrap that I made, but it gives you the idea that all of these are the same rail and stile bits, and yet we have divided lights in here. Kind of interesting to put panels in between these. Maybe this is a drawer box front. On a big scale, there were 3 of these on my son's bed. So the idea is rail and stile joinery provides one of the best ways to take end grain next to edge grain. It adds some really pretty look on the end of this. You get a real nice visual appeal from it, and the raised panel just even adds more interest yet. So that's the story on doing this. Again, you won't have any trouble at all, and you'll be surprised at how pretty these look and how interested you'll be in having somebody come over and look at something so that when they look at it, they're going to say, boy, that's really pretty.